Hey, it's Mr. Solitano. This video is going to be talking about the periodic table of elements. And so it's really easy to forget that the periodic table didn't just exist with the dawn of humankind, right? It wasn't just always there. It's something we've seen in our lives a lot, but it's easy to forget that somebody had to come up with this, and somebody had to organize the elements in just such a way. And it's what some call one of the crowning achievements of mankind to create this table. And what you'll find is, I find it very, very interesting how all of these elements just happen to fit together in just such a perfect way that the patterns that we'll be talking about, because this isn't random at all, there are very many patterns that all fit together in the periodic table of elements, and it kind of lends sort of a magic to life as to how is it that it could be that these all happen to fit just so with the patterns that you see. How is it that the elements all happen to be this way? So that's what we'll talk about. And we'll start at the beginning. So this is one of the earliest scientists. So imagine the year is 1829. And the atomic masses, right? So that's one of the earliest things they were able to determine about elements are their atomic masses. About 60 different elements have been determined. Now it's not necessarily these ones that I have up here, but about 60 of them have been kind of studied. And so you're a scientist, how do you begin to organize the elements to try to find a pattern, if there is a pattern at all, really? So one scientist, J.W. Dobereiner, his idea was to classify them according to how they act similarly. So how are their properties similar? How do they react similarly with other chemicals? And so he decides to do that based on their properties. And specifically, he grouped them together in elements that act similar to each other and have orderly differences in groups of three called triads. So tri means three, right? That makes sense. So he just thought, I'm just going to go with three at a time. I noticed three groups of elements that tend to behave similarly. So for example, one of those triads was chlorine, bromine, and iodine. So that was just one example. And so he picked those three, and here's a picture of them over here. And started to realize that, so the concept of triad suggested that the properties of elements are related to its atomic mass. So he started to notice that as you transitioned in mass from element to element, you saw different properties emerging. So what was interesting is that the chlorine, which is the one on the left here, was a gas. Bromine exists naturally as a liquid at room temperature, and iodine exists as a solid. Now, when you compare their atomic masses, so bromine being a liquid, you think of that as being sort of halfway between a solid and a gas, right? Well, its atomic mass was also about halfway between iodine and chlorine. He found the densities. The density was also in between the two. The melting point fell in between the two, and the boiling point of bromine also fell in between the two. So as you went up in atomic mass, he noticed that other properties tend to change in relation to that. And that the middle one was sort of an intermediate or an average. So that was interesting. So right away we start to see, it doesn't seem to be just random. There seems to be a pattern here where as you go up in one direction, other properties change accordingly. So that's kind of where we get started. And there were other triads that he discovered as well. So calcium, strontium, and barium, for example, he put together as another triad. The big deal, the big guy, one of the most amazing inventors, well, I guess more discoverers of all time, was Dmitri Mendeleev. He was the one accredited with developing the first real periodic table of elements. Now, it's not the same one we have today, but he was the one who kind of developed the original periodic table. And there's something else he did which was huge that we'll talk about in a minute. But yeah, so he developed one of the original periodic tables. His name is Dmitri Mendeleev. So you have kind of a simplified example here. Dmitri Mendeleev had like an encyclopedic knowledge of all of the elements that had been discovered at the time. He dedicated his life to discovering the elements, essentially. He was stubborn and determined, and he knew everything there was to know about them. And he thought, sure, there had to be some pattern with the elements. There had to be some way, sort of like Dobereiner said, but not just in groups of three triads, but he thought the whole thing, there's got to be, it just seems like there's got to be some way they all fit together with each other. So he put the elements on different cards, sort of like flashcards, and he moved the cards around trying to figure out how do these go? There's got to be a way that they can all just fit nicely. And so he's trying to solve it, and he just keeps getting stuck, as there are other scientists hot on his trail as well who were trying to figure this out, and they all got stuck. And so what we're looking at here is we see a bunch of different competing properties in these elements, right? Like some of them have some similarities, but yet they're still different. So we have shapes we're trying to make organized, numbers we're trying to make organized, background colors. These are kind of metaphors to the properties of the elements, the atomic masses of them, things like that. So he was trying to get all these properties working and get the atomic masses to also go in a set pattern. All of the things working it together so that everything would fit in the pattern. A bunch of competing things to try to make work in a single pattern. So he gets a lot of the way there, right? So he organizes them pretty well. And he realizes that the problem he's having is that actually there are things missing. No wonder we can't solve this puzzle. Imagine you're working on a jigsaw puzzle and there are just pieces missing. And so he realizes that, okay, I can organize these, but there's just pieces that are missing to the puzzle. And he also, and this is why another reason why he gets all the credit as a big deal, he makes a prediction that not only are there, why he couldn't find the pattern before was because they're missing elements, but he thinks that those elements do actually exist somewhere, we just haven't discovered them yet. Mankind hasn't discovered those elements yet. And because he's so certain of his pattern, he's so confident in the patterns that he developed with his periodic table, that he actually makes predictions about those elements. He predicts, okay, well this gap right here, this element is going to behave like this, and it's going to have these properties based on the elements around it. Same thing with this missing element, maybe that missing element. And so you can kind of do in a similar way what he did, right? So if you look at this, you can kind of take a guess that, okay, this missing element up here, based on the pattern, is going to be an octagon, right? And it's going to have a gray background based on these patterns. And the number, maybe we'll call it the atomic number, for example, would have to be 2. So he developed the periodic table with missing elements, and he made predictions about the elements that were missing. And he was right. That's the crazy thing. So when they did finally determine those elements, once we kind of discovered more elements and filled in the rest of our puzzle, he was correct in his estimates because his pattern was so true. The periodicity, the pattern that he discovered. So it's just sort of an amazing thing until we eventually have sort of more like the periodic table of today where the things are actually filled in. So those are his big things, Dmitry Mendeleev. So what Mendeleev ended up doing is he grouped the elements. So he put the columns based on families, so based on similar properties essentially. How did they act similarly? And then he had them go increasing atomic mass from left to right, and also from top to bottom was increasing atomic mass. So we notice again that as the mass increases, we see those patterns follow. And you kind of see how these are all going together. For example, this looks like our triad that Dobereiner had developed, and also the halogens over here were like another one of the triads. See the FCl, Br, were like another one of the triads that Dobereiner had originally sort of discovered. Now, this is not, even then though, he still doesn't have it like the current periodic table we have today, but it's another step in the right direction. The properties are all in one place, the masses are all going in a certain direction type thing. And so that's how he did it. And this is still not the exact modern periodic table that we have today. So at the time when Mendeleev did this, there were about 70 elements discovered, and he put them in 8 columns with similar properties and increasing atomic masses. And again, he left blanks and predicted the elements that were missing, and he was correct. So that's what's interesting, his claim to fame. So this is what his periodic table sort of looked like, and again, notice the gaps and of elements that hadn't yet been discovered. Okay, now we're on to today's periodic table. So the way that we arrange the periodic table today is based on what somebody named Henry Moseley said. So in 1913, he arranged them based on atomic number, right? So their proton number instead of their mass. And that's how we essentially do it today. If you look at a modern periodic table, it's arranged by the atomic number. So it goes 1, 2, and then 3, 4, keeps going that way rather than masses. So from left to right, we have the atomic numbers going across. So let's talk a little bit about periodicity. So it's the tendency to recur at regular intervals. So for example, the 4 seasons occur at predictable times, right? Your classes have predictable times. Periodic law has to do with this. So periodic law says it's the statement that the physical and chemical properties of elements repeat in a regular pattern when they're arranged in order of increasing atomic number, and that's known as the periodic law. So let's take a look at what that looks like. It's a lot like the weeks in the calendar, for example. And that's what's so amazing about the elements. Like, it just kind of can't believe that they fit together so well like this. So for example, as we arrange them properly, we have, for example, here we have hydrogen, which has 1 valence electron, and then helium has 2 valence electrons. But then as we go down, we start to see this kind of periodicity appear even more. So lithium also has 1 valence electron, and then beryllium has 2. And then we've got 3, 4, 5, 6, 7, 8 valence electrons. And then if we go in the next period, right, or the next row, we see the same pattern. 1 valence electron, 2 valence electron, 3, 4, 5, 6, 7, 8. So the periodicity, it's repeating in a periodic interval. It's a lot like the days of the week that we see up here. We know that we do certain things on Sunday, right? There's no mail on Sunday, for example. On Monday, we'll probably have school. And then the days of the week, we'll have probably certain classes, certain things happen. And then when we get to the next week, technically we're later in the calendar, right? But the days will repeat again. We'll have a similar Sunday. Monday we'll start school again type thing. That's exactly how the periodic table works, where if you go in the columns, they have similar properties. They're similar to each other. As we go from left to right, the numbers do increase. We are kind of progressing. Atomic number goes up and things like that, just like the numbers on the calendar go up. So that's what's so kind of incredible about the periodic table, is that it's kind of a wonder of nature, that all of these elements work together so that we can arrange them in just such a way that they have predictable repeating patterns. To the point where if you know nothing about an element, you can look at what's around it and make a prediction about what it would be like without even ever touching it, just like Mendeleev did. So that's the video on the scientists and the periodic table. Thanks for watching, and as we saw here, chemistry is everywhere.